Hello, everybody. Welcome to the Unix User Association of Southern California, May 2017 presentation. My name is Jordan Schwartz. I book the presenters for the UUASC LA meetups. So we're going to go through a little UUASC business and then get a word from our host and then get on to two presentations. The first being Will Rosecranz's talk on Malloc in Userspace and why you kids in the cloud should care, and followed by Bob Reislman's talk about after we've automated everything, then what next? So two interesting talks that have been were cherry-picked from the DevOps Day LA at scale, was it 15x? That occurred in Pasadena a few months ago. But before that, I just want to kind of go over the whole UUASC bit. Main thing about the UUASC, it's one of the older tech meetups here in Southern California, or LA. We're called the Unix User Association because I think when the meetup started, Linux hadn't been invented yet. So, you know, hindsight being 2020, if we had only known, we could change it. So, but actually, any Linux variant is welcome. I mean, we discussed that all kind of stuff. And the main thing to be a member of UUASC, you should join our mailing list. Is there anybody here that is not on our mailing list or not familiar with our mailing list and would want to be on it? I guess, okay, so anyway, at uuasc.org is our website, and there's a link there to join our mailing list. Or actually, we have three mailing lists. The first one is the main mailing list for discussion of Unix, things with a Unix or Linux related tangent or beer. Also, there's another list called UUAC Announce. That's primarily for meetup announcements. And then another one called UUAC Jobs. That is for Unix or Linux related job postings in the Southern California area. It is a non-moderated list. So if well, it is, yeah, it used to not be a moderated list. Oh, well, anyone can submit to it, and then if it is actually a valid request, our mail administrator, who is heckling me from the crowd, will forward it on. Also, if you're looking for work, you could post up there with some text and a link to your resume or a link to your LinkedIn page. Once again, you know, we could be more stuff with LinkedIn, but we kind of predate that for a few decades. So there's the three mailing list. That's the main thing. And of course, the other thing is to be a member of our meetup site. That's meetup.com/UUASC26. I don't know what the 26 is all about, but that's also a good way to kind of keep up what's happening with the meetups. Also, we try to meet on the first Thursday of the month here in the usually on the west side. Because it's convenient for me. And I'm always looking for speakers. Although I have the next couple of meetups booked up, I'm always looking for presenters. So if you're interested in presenting at UUASC, send some email to leaders@uuasc.org with maybe a title, a sentence or two about what you wanted to talk about. Something like that, and we could perhaps work something out. Next, I have the next 2 months booked. Next month, Randall Schwartz, who's author of some Perl books and the host of the Floss Weekly Show on the Twit Network, will be here talking, doing a talk which is something like Beyond 12-Factor Applications. He's working on a book for O'Reilly, and it should be a very interesting presentation from my cousin Randall. So we'll see you here the first Thursday of the month, which is maybe June 1st or whatever. Go to the meetup site for the details on that. I guess one other thing, I should note that we are, well, actually, let me run through this. And then the meetup after that, Puneet Kandahari, who's a an engineer here at Verizon Digital Media Services, will be doing a talk about basically about chat ops, using chat channels for server provisioning specifically. So there's some interesting work he's been doing, so I brought him in to talk about that. So with that said, I'd like to thank our host, Verizon Digital Media Services, for providing the facility here, the food, the drink, which if you happen to be in Meat Space here, the tacos were awesome, foreshadowing Cinco de Mayo tomorrow. And also, they're providing the technology for this live stream feed that you folks out there in TV land are watching. The live streaming is happening through a service called Uplink, which is one of the services provided by Verizon Digital Media, also including the good old Edgecast content delivery network, which I happen to work on. So I'm going to bring up Tamira James from the Verizon Digital Media Services core evangelism team to just do a little quick wrap about the interesting stuff we have going on here, and then we'll get into the prezo. So come on, Tamira.
Hello. Yes, so as he just mentioned, my name is Tamira James. I am the core development evangelist here at Verizon Digital Media Services, and I'm a little tall, so this thing is okay. Okay. First and foremost, welcome. If this is your first time, welcome to our lovely space. And also, if this is not your first time, welcome back. Glad to see you again. A special thanks to Jordan, who is, I don't know what I was about to call you just then, but Jordan, who is just an amazing person and so helpful and a huge contributor to our evangelism efforts here at Verizon Digital. And he's just an awesome guy all around, as you know. So special thanks. And so now I'm just going to get into, the fact that the reason you guys are here is just a part of, not only just a part of the UUASC initiative, but also the fact that our evangelism team has now increased our meetup max to 4 a month. So our goal is to hit 1 a week. So we're going to be hitting meetups left and right. So if you are a meetup organizer or you're a part of an awesome meetup group and you just want to tell your organizer, hey, there's this awesome space. We usually provide the space, the beers, as you can see, all the great food, free parking, all free of charge. All we ask is that you follow us on Twitter. No. But yeah, right? And retweet, right? By the way, plug. So our Twitter, our social media, we do have an engineering account, which is, okay, and everyone's going to want to pull out their phones later, but I'm going to shout it out right now, which is Engage. So that's ENGAGE_VDMS, right? So just go ahead and follow us on Twitter. You're going to want to. I'll tell you why later. So here are our upcoming meetups, all for this month, the month of May. So on the 25th, we'll have the LA Wi-Fi meetup. And basically, we're going to have a bunch of Raspberry Pis. We're going to get together and build mesh networks from scratch. Yeah. And VDMS will be sponsoring the Raspberry Pis, by the way. So, yeah, right? And then Tuesday, the May 30th, we're going to have the SoCal Python meetup. And then on the 31st, we'll have the Data Science LA meetup immediately following that. So we've got a lot of things coming up. And then, of course, as Jordan mentioned, June is going to be busy as well. But I think for June, we have maybe 2 more spots available. So be on the lookout. Speaking of Engage, we do have a new engineering blog. This is our URL for that. I see you taking pictures. I'm going to leave this up for now. Yes. Yes, this is a new initiative that we have here as well. We have great blog posts that cover the what we're doing under the hood. Is he? Oh, is it? Well, are we gonna? Okay, so maybe later we'll update Will's blog post. By the way, he has a blog post with his slides from Scale, and that's the talk that he's going to be doing tonight as well. And then we'll probably update it. We'll upload the stream from tonight on there as well. We'll update. Yeah, eventually. So, Will's talk, as well as a lot of cool things that we're doing under the hood, anywhere from security to, what's going on the CDN, on the streaming side, just a lot of the challenges that we have on the, just on our technical front, all going to be covered on Engage. So that's the URL. Also, we have recruiters in the house. I don't know if they can hear me, but the lovely little lady in the front, her name is Stephanie Stein. She is our lead tech recruiter. And yes, we have a bunch of openings now. So it doesn't matter what you do. We probably have an opening for it. We have openings for products. We have openings for security. We have openings for data science, you name it. So you're probably going to want to talk to the lady in the front before you leave. I'm sure they have cards as well. Okay, with the feedback. I think he loves the sound of my voice, actually. I can't. Now I don't feel so bad for the Jack reference. I don't. Right. We're still getting together. Okay, all right. Okay. Like I said, so follow us on Twitter. We are trying to build our technical presence, and to give even more incentive, we are gamifying it. I'm going to let you know. Not right now, but later on, I'll let you know why it's important. I just want to tell you, you want to follow us. You want to follow us. There may be swag involved. I'm just saying. So I think that's it. I'm not going to take any more of your time. You're like, okay, get to the prezos, and that is all for me. All right.
Thank you, Tamira. And one other point regarding the SoCal Python meetup. There will be a local VDMS engineer, John Hickey, doing a presentation there. And we also, aside from the engineering blog, we also have a GitHub repo as well. And he'll be talking about a Python library he developed called Dractor, which is for managing Dell server iDRAC module. So if you want to automate configuration and provisioning of your Dell servers, John Hickey's Dractor might be a cool way to do it. So you'll see that at the May 30th meetup. And all the meetups hosted here, we should be streaming on Uplink as well. So with no further ado, let's bring up our first presenter of the evening, Will Rosecranz.
Hello, hello. Let me switch over the presentation here real quick, hopefully. All right. Yes, so I am Will Rosecranz. I work here at Verizon Digital Media Services. I'm on the HTTP platform team, and I want to talk to you about Malloc. Because it's something that is very simple, can be very thoroughly explained in like the first day of a CS 101 class to give you like 99% of everything you will ever need to know in like a couple of minutes. And it seems like a very simple thing, but I enjoy sort of picking apart what seems like very simple things. And I sort of figure at a meetup like UUASC, there will be about 50% like longbeards who have kernel commits, and like 50% people who are learning Ruby on Rails, and neither of you are very interested in my topic, but if I average the audience together, all of you are on average super interested in this. All right, so I work at a CDN. We deliver terabits of traffic. A non-trivial percentage of the traffic of the internet goes through our systems. And basically we run caching proxy servers. I don't know exactly why it looks like that with the image duplicated and bigger right next to it. I work on lower level things than PowerPoint usually, so. But yeah, in order to serve terabits of traffic and as much traffic as we do, we need to worry about some kind of low-level optimizations in order to get the performance that we're looking for. So we wind up digging into some things, and hopefully I will convince you by the end of this that you will occasionally need to worry about these things too. That is, I have no idea why it's smaller and inset. It was not doing that when I did AV check before this. So what is Malloc? Like I said, it is super simple to explain the way you would encounter it in ACS 101 class. If you don't write C, you may not have run into it directly, but you use it at least indirectly. It is a way to ask the system for memory that you can use for stuff. So if you want to store an array of data or a string, you say Malloc, the amount of data that you want. It gives you a pointer, a memory address that you're allowed to use as much data as you have asked for, and then you can do whatever you want. You can store the number 42 in it if you don't have a very complicated application. If you have a more complicated application, then you'll do more interesting things with it. And that is, for most people, like a really thorough explanation of Malloc. You get memory from the system, but I mean, a lot of people are not writing C, and you kind of don't care about this. So if you're writing, say, Python or Ruby, you're going to say, well, I don't deal with low-level memory allocation. I don't deal with pointers. I don't deal with any of that stuff. But the software that you're using does. This doesn't go away. This is sort of fundamental to the way systems work. I'm going to be talking about Unix directly, but on Windows, it's really not that different. The fundamentals of operating systems are more or less the same. I sort of ran through the Python, CPython runtime is written in C. The standard Ruby implementation is written in C. There are alternate implementations of Ruby and Python. For example, there's a Go Python implementation, and there's Ruby that runs on JVM. But Go itself links to the standard C library and calls Malloc, and the JVM will also call Malloc. So even if you're using a platform where you're very far abstracted from this stuff, it still affects what is happening on your code. Even if you're doing like very high-level web apps, even if you're trying to, you know, hey, we are serverless, we don't interact with native code at all, we don't see any of these low-level details, they are still there and can try to really ruin the performance that you're seeing. And a lot of people have been kind of musing about Malloc recently. I ran across a blog post from the author of curl that he posted just within the last couple of weeks. I don't remember the exact date of this, but it was kind of interesting to run across somebody else thinking about kind of the same stuff that I've been thinking about. He realized that he was using a couple of hundred kilobytes of memory, but he was doing tens of thousands of memory allocation calls because he was getting memory from the system and then he was disposing it and then asking for the same amount of memory again. And it was an incredibly inefficient process, and he was able to increase the speed that curl can transfer data in the best case by over 600 megabytes a second by removing unnecessary curl calls. And if you've ever priced bandwidth, 600 megabytes a second is actually kind of a lot. And if you can get that kind of a success just by doing a little tweak to an application code rather than spinning up 100 more instances of EC2 VMs in AWS or something like that, there's a huge financial benefit for you to find a way to make something more efficient like that. So Malloc is guaranteed to get memory from somewhere, but there's no very strong guarantee what exactly happens when you call Malloc. The standard definition is that Malloc gets memory from the system. And if you look at, say, the C programming language specification, it's going to be super vague about where that memory actually comes from. And the most obvious explanation is that the system means the operating system, the kernel. And The kernel is responsible for managing low-level details like memory and hardware. Memory is hardware. Ultimately, it goes on physical sticks of RAM. So you expect that when you call Malloc, you're always going to talk to the kernel and ask the kernel for some memory that you can use. But system calls are really slow, and every time that you have some user mode code that has to talk to the kernel, the processor has to do a whole bunch of stuff to switch which mode it's running in and be executing in different address space. So the standard C library will try and avoid crossing into kernel as much as possible. So the first time you call Malloc, it will do some low-level stuff to get kind of a lot of memory, no guarantee how much, and then it'll give you a little bit of that memory. What that means is when you run something like top, you're always going to see your application using more memory than you know about if you allocate a certain amount of memory and you look at the code and you're reading like, all right, I know I have allocated exactly this many bytes of memory. Why does top say I'm using 4 megabytes of memory for this? It's a very small thing. It shouldn't be using anywhere near that much. In order to avoid all of these system calls, it gets memory in batches. And there are a couple of ways that it gets those batches of memory. The main ones are system calls called SPERC and MAP. And the way those work is SPERC grows memory from the bottom of address space up. It starts at sort of address 0 and increases in numbers to give you more room at the bottom of your address space. And mmap, in general, it has a bunch of modes and flags and things. But generally speaking, it allocates from the top of address space. And once they meet, you have allocated all that you can, and you are stuck, and you should use less memory, and that's not my fault. And knowing that there are these two different modes is kind of important later. It's going to be fun. This is all sort of inspired by an actual problem that we ran into a while back. From an external view with utilities like top and things like that, you are never seeing the amount of memory that you have malloced. You are seeing the amount of memory that Malloc has gotten from the kernel. So when you're calculating the amount of memory usage of a process and things like that, the internal and the external perspective are very different. Because, and this is sort of the whole point of the Muse, Malloc lives in userspace. It is entirely equivalent to the code that you write. You could be talking to the kernel directly to allocate memory more efficiently. From outside, the difference between Malloc and your code that you have personally written is just sort of which file it happens to live in, but external tools won't see that when you're trying to debug a system and trying to understand where all your memory is going and who's using it and which guy you need to fire because he used up all the memory on your server. So Malloc has a very special friend called free, and you probably know you don't want to just Malloc memory and then hang on to it forever. If you are running a server, it's a long-running process. Eventually, somebody else is going to need that memory. So you free the memory, and obviously, in the general definition, memory goes back to the system, which is vaguely left implementation defined and left to vary between operating systems and versions of operating systems and things. But when you free memory, it is not guaranteed to go back to the kernel. So because Malloc is getting memory in chunks, at least one page of memory, the exact size of a page, depends on your particular platform. As long as any memory is still in use on a particular page, it does not go back to the kernel, ever. The system cannot return it as long as there's anything on there. And it cannot shuffle memory around inside your address space. So what can happen? You Malloc 4 kilobytes of memory, you leave 1 byte in use and you free it. That whole page is still used. If you multiply that process by, say, 1,000,000 times, you're going to be using a massive amount of memory, which is from your application code, which is entirely correct, is 1 megabyte of memory. That if you look at the counters and run a memory profiler, you're going to say, I have allocated 1 megabyte of memory. That's all that's left that I've allocated. Why is it using 1,000,000 or 1,000 times that much? The things that the system can do is it can rearrange how your process's address space is laid out in physical memory. So it can shuffle it between physical sticks of memory, and when it's swapping, it can make it wind up on disk. It's not even on memory. But inside your address space, there's no ability for the system to rearrange things for you to compact that memory. If you're using a language like Java, the Java virtual machine can do that, but that lives in user space. It's not kernel. The kernel can't enforce that reorganization. It's a part of the runtime inside the language that you're using. There is no generic way for something outside of your process to move things around in a way that your process would be able to understand. Java makes guarantees inside its own process. It chooses to keep track of things so it can move its things around. But the memory fragmentation that you can get is sort of independent of what language you're using. It's just sort of a fundamental of the system itself and the way that memory allocation works. Okay, so there's this thing called Malloc, and it lives in user space. There's this library file on your system called libc that you link to. You get this implementation, and it's this code that you could write. You could be talking to the kernel directly, but that's hard and super boring and not very portable. But there are other people who have done that. So Google has a replacement Malloc called tcmalloc, and there's another one called jemalloc. And if you link to these libraries instead of the standard libcmalloc that comes with your system, you can get completely different behaviors. You can get all sorts of instrumentation so that whenever you call malloc or you call free, it can increment a counter and decrement a counter. And if you use Google's tcmalloc, which is something that we're big fans of here, you can send a signal to the process. The C library that you're linked to will intercept that signal, and it can spit out a table like that of which things are allocating all the memory inside of your process, what's actually happening. And it also has the ability to sample performance for CPU time, things like that. So by using an alternate malloc implementation, you can get something that is potentially going to make your process use a whole lot less memory, make memory allocations a whole lot faster, give you a whole lot more insight into memory allocation. So you may want to use different mallocs in test versus production because they have different properties. And if this was like a really long talk, I would probably do like a demo here of like how easy it is to link to different mallocs and try and go into comparisons. But I just want to throw it out there that there's a bunch of stuff you can Google. And even if you are deploying at very large scale things like Python, you can potentially link your Python runtime to different malloc implementations and benefit from the different performance characteristics that these implementations have, because they all have slightly different allocation algorithms for when they're going to hit kernel space and when they're going to get a really big chunk of memory. And another thing that you can do with tcmalloc is control whether it is using sberk or mmap, and starting from bottom of address space or top of address space, which seems like a super obscure thing that you would only care about if you're writing like super low level code. But it turns out if you're writing Lua, you may also care about that. Because we used to use a Lua implementation called LuaJIT, which was originally a 32-bit Lua implementation that got very hastily ported to 64-bit and wasn't super 64-bit clean. So in order to allocate its memory, it used a really weird mmap mode to only allocate memory in the first 32 bits of address space. And it did it toward the bottom of address space. So at a certain point, what was happening, because we have all sorts of Lua scripts that control dynamic behavior in this web server software that we have powering the CDN, we load lots of configurations and be using, more than 3 gigabytes of RAM. And then we would load the Lua runtime, and it would try and allocate memory inside the Lua scripts. And all of the memory in the range that it could handle was already allocated. So it would try and call this obscure mmap, and then it would just fail, and our server software would crash. And it was very confusing, because we thought these days, in the 21st century, everything would be sort of 64-bit clean. But sometimes that's less true than you expect, including with languages like Lua, which don't let you see any low-level memory allocation details. But like I said, they can still come and bite you, even if you can't see the details. I mentioned we use Google's tcmalloc implementation. It has a couple of environment variables that you can set. So we told it, well, we're using too much memory in this range of address space for Lua to work, so we can flip it into the other mode where it's allocating all of its memory from the top of address space. And we set it to not use sberk and use mmap instead. And that made it work for long enough to change to a different Lua implementation that was actually 64-bit clean. But when production is having a dangerous outage and things are crashing, you can't necessarily just say, well, we're going to port our software to a new platform in an hour. You wind up needing tweaks and knobs and controls that you can do to mitigate the problem before you can solve it. So that proved super useful. And not something that we would have been able to do if we hadn't understood which parts of our address space were filling up at the time. So there is a really cool optimization in Linux. Whenever you fork, it uses a technique called copy on write. And you fork all the time. Whenever you run a new process, for the most part, there's various ways to run it. But one of the most common is to fork. If you run a process in bash, it will fork. Bash will still exist on one side of the fork, and then on the other side of the fork, it will load the process that you're trying to run. When you fork, you have all of the memory that you had allocated before you forked in both processes that fork results in, which sounds super slow because it should have to copy all of the memory address space. But what it can do is just not copy it over, do the fork, have everything pointing to the same area, and then just whenever you try and write to memory that has been allocated, it'll make a copy of it so that it actually has a copy on the two processes that have resulted when you fork. Yes?
Does it copy just the portion that you're actually changing or everything?
Just the portion that you are changing.
Can you repeat the question?
Yes, the question was, when this copy on write happens, is it copying the entire address space of everything that is allocated in the process, or is it copying just the chunk that is changed? And there's a granularity to it. It'll be based on page size. So there is if you try and write a byte, it may try and write megabytes, depending on exactly how the system is configured, but it will not try and write gigabytes. So it's a lot faster, and it's this great optimization. But one thing that can happen is you've got this code that works great on your laptop. You can fork, you realize you're not using that much memory, you spin up all of these processes, you load some configuration data or some data that you need to process, you fork into like 16 different processes, you only have to read it off disk once, it's all in memory, you never write to it, even though your laptop doesn't have a ton of memory on it, it's this really efficient process. Then you try and deploy it to production and you're like, I've proven this is fast enough to run on my laptop, the server is so much faster, this is gonna run great. But the server is a dual socket server. Those are pretty common. There's separate physical CPUs. Each is physically connected to a different bank of memory. And the system is trying to decide, well, where should this data live that I read once and I only have one copy of, and I'm running a bunch of processes that are all trying to read from it on these two different processors, this big server that's got a bunch of capacity. The operating system, Linux, will try and move the data to whichever processor is using that memory. So if you have code running on one processor, it'll go, this memory belongs over here. And you have no guarantees about how memory inside your address space maps to physical placement. When you swap, it winds up on hard drive. It's not even in memory, so the kernel can shuffle that all around. But then you have, the process running on the other processor because you're running a whole bunch of stuff in parallel, and it goes, oh, well, this other processor is actually waiting on memory a whole lot. I should copy that data from here and make it live over here, connected to the second processor. But you've only got one copy of it, so the program running on the first processor is now really slow. And so this really cool optimization that saves you one copy is now ping-ponging data back and forth because it can't make up its mind. And in order to save that one copy, it's doing a couple of million copies over the lifetime of the program, which is an interesting thing to run into when, for example, if you are doing AWS Lambdas and you're running Python, you can get into situations where you're running on systems that have that NUMA configuration. They have multiple processor servers. You're not really guaranteed what you're going to be running on in the cloud. And if you have the same data that has been read in multiple processes, but it only has one physical copy, it's just ping-ponging back and forth. The system is doing lots of copies, and you wind up paying for a whole bunch of extra time in your AWS Lambdas, which is not fun because you were really hoping to be abstracted away from any of those low-level hardware details. And literally, what you pay for with AWS Lambda is megabytes and seconds. So as there is this increasing trend to get further and further away from the hardware and worry less and less about low-level implementation details, if you get popular, which, I mean, hopefully popularity doesn't happen to you. But if you do, you wind up in this situation where you haven't worried about any of these low-level details, and you think, I'm using dynamic languages. I don't have to worry about memory allocation directly. I'm using the cloud. I'm not seeing hardware directly. And then memory allocation on specific hardware configurations winds up charging you a ton of money because you've written code that runs very slowly and uses way more memory than you think it does. And that comes out of your beer budget, which, what? Yeah, I mean, if you write efficient code, you can have enough beer budget to host meetups. It's great. So thank you. We also have a short URL for the blog. It's blog.vdms.io. I don't like typing, so it goes to the exact same URL that Tamara said. And this talk started out as a DevOps Days talk, so we have the original version of the slides from that posted there, and we'll probably update them with the 1 or 2 extra slides I had. And then there's also a bonus slide if you want to download the slides that I decided was too boring even for me to want to talk through, because the slide is like 50% fine print. But when you're reading data off of a file system, your process never reads the disk directly. It's all going through the system. It gets copied into a memory buffer, and your process is getting blamed for the memory buffer. There's a bunch of copying happening, and there are lots of circumstances when I/O problems that you want to blame on the hard drive are ultimately memory problems because you assumed memory was fast and you were wrong. That's all I got.
Hey, thank you, Will. Does anybody have any questions? Mark? Come on, I see a question stirring around in there. Bob, did you want to throw down your question?
I covered you earlier.
Okay. All right, Will. Thank you very much. Sure. So we're going to take a little break so that we can set up Bob's laptop for the live stream. And then he'll be talking about, after we've automated everything, what next? A cautionary tale.
Cautionary tale. So I need some help.
Oh, hey, did anybody, hopefully y'all read the meetup spiel and parked on Coral Tree Place, but did anybody drive in the big metal gates? Okay. So talk to TJ. She will handle your validations. And I appreciate if you did park over there, it's much better they rake us over the coals for the parking. I'll put it this way, park over there, more beer. Okay. So anyway, I got to go deal with this. Displays. That's the first thing.
Hold on a minute.
And also we have another option.
Let's see.
Okay, good. Hey, you're on the projector and you're on the main screen. So
good.
as far as I'm concerned,
everybody can see my thing. Right? Hold on a minute.
Oh my God.
That's all right. Don't worry about it.
You're in open kimono mode.
There you go.
Okay.
We're good?
So you're good, and that's on the thing. All right,
Okay,
so good.
good.
Let's
Let me get my thing.
good. Okay. So it looks like we're ready to roll. In a second here, Bob Reislman will be up to do his talk about the impact of automation on human employment. Wow. So take it away, Bob Reislman.
Oh, thank you. Wait. I got to make sure things work. Okay, that's good. I wonder if my kids are tuning in. I've never been, I'm like worldwide now. First of all, Will did a great job. He's like my new hero. He's like my new, I'm going to build a little altar in the northwest corner of my living room, you know, and a little thing with a picture, incense. It'll be very nice. Okay. Well, thank you for coming. Thank you for inviting me to speak here also. This is a topic that's really very important to me. And the reason I got into it is I'm going to be up front. The November election sort of was like unexpected. I mean, everybody was telling me things were going to happen, and then they didn't happen. And one of the things I heard was that the memes, the themes, the talk, you know, the bloggers here saying that the jobs are going to come back. You know, the jobs are going to come back. And I decided that that it wasn't making sense to me. It just wasn't making sense. And I decided to devote a good deal of my time to really researching this and understanding what was going on to the best of my ability. Now, before I begin, I need to tell you that I'm not a Luddite. I've been doing technology for a while. I can sling code. I don't go down to where Will is. I know Malloc used to be my friend, but we had a parting of ways. We just separated. And it wanted more from me than I was willing to give, but that's what it is. But I do write. I write for a number of technical journals. I write there. But I went back to my publishers. I said, look, I got to pay attention to this. It's almost imperative. And they were good enough to start funding me to start writing about these things and start funding research, which I've been doing pretty steadily since November. So there's some stuff out there. I need to say, look, going back to, I'm not a Luddite. I'm a big believer in technology. I made most of my living. I put my kids through school. Technology has been very good to me. So I'm not here to tell you it's bad, it's awful, to go back, we should all go off the grid, and live on wind power. That's not what I'm saying. This is a picture of a textile mill. I think it's around 1880, 1890. And at that time, there were no child labor laws. As a matter of fact, most children worked. They didn't go to school. Most children worked. And a lot of children with the industrialization in the Northeast went to work in factories. And they're very attractive to textile factories for a very simple reason. They're short, they're small. So children can get under the machines and then get over the machines. Adults have that sort of problem called navigation. And I'm going to talk about navigation. Let me give, I was negligent. Let me give you the roadmap. I'm going to talk, my third of my talk is going to be about the way things are now. Then my other third, I'm going to talk about five factors of impact. And then I'm going to talk about the 3 challenges. This is going to be about a 45-minute run. I'm going to try to be as entertaining as possible, as interesting. So if I'm not interesting, you can just start raising your hand or leave or tell Will, and he'll come back up here and we'll move on to CMOD and users. But anyway, so this part here, though, is that children got around the machinery very easily. And as you were a child, and you're 8-year-old and 9-year-old child, this was your future for most children. This is what it was like. And, we're the good guys. We actually, child labor laws passed, but also automation, particularly factory automation, removed a lot of children from factories. Okay? And children got a chance to do a thing called go to school, and you became educated, right? And you had a thing called a childhood. And most children today, except in very horrific parts of the world, have a thing called a childhood. And technology brought us that. So this is I think I turned the sound down. If it's too loud, please excuse me. But this is what a modern loom looks like. That's what we turned that's what happens now. Notice there's a particular absence of human beings. Notice the speed in which the fabric is being made beyond the capability of any human being, for sure. That's what it looks like. This is an assembly line in 1930. I don't know if it's Ford or Chevy or any of that. But has anybody here ever worked in a factory or a warehouse or driven okay, 1 out of 20. We got a 5% here. I did. I've worked in factories and I've worked in warehouses. And industrial processes are very much like computer programs, okay, in the sense that every job is well known. An industrial designer or a plant manager knows every job that needs to be done on the line. Each of those jobs are numbered, they're graded, their pay grades are assigned accordingly, and there's a seniority system built around the job, so the more longer you've been in the factory, the more you can move into seniority and move into either more attractive jobs or safer jobs. A friend of mine worked in when I worked for Gateway, for 4.5 years. I lived in Sioux City, Iowa, which used to be a meatpacking part of the meatpacking. That's where most people made money. And I had friends that were meatpackers. They worked in actually still some of the packing houses. And a big job, escalating through the job, was going from the floor to the laundry. Working in the laundry, that was a seniority job because it was very safe. The clothing didn't attack you and there was no knives wielding. But anyway, and going back to a factory, all the jobs are very well known. And so humans fulfill really robotic chores. okay? And you would, so your job would be like put you know, the windshield in, or put the hubcap on, or put on the carburetor valve, or attenuate the carburetor. Very, very well known. And you could be trained to do a number of different jobs, but you almost say you had to be certified. This is what a modern factory looks like. Notice something missing? Yeah. Now, a friend of mine does automotive industrialization, and he knows this stuff real well. And he told me that there's still about 25% of automotive industrial production is still needs human beings, but that's only about 25%. 75% of it is robotic. Okay, and that's, you know, there you go. And then the other one, this one's my new favorite one. This is by Komatsu. This is an earth-moving pickup truck. It's completely driverless. It's autonomous. But look at the size here of the pickup truck. That's a real pickup truck. And look at the size of that thing. So this thing is being run robotically. Yeah, and it is, and it's done. So this whole notion of mining, bringing the mining job, companies do not really want to hire unless they have to. And if you're doing dangerous jobs, which is, you know, compliant, it has to have OSHA compliance and stuff, you really do want to have a machine doing that. And they work 24/7, and they're exempt from OSHA compliance. Yeah, so robots are there. So anyways, that's pretty much where things are going. So let's talk about robotization. And this is, let's talk about machines. Automation and robotics are really going into what we call thinking machines. Thinking machines. And there's a guy named Benjamin Bloom, and he was an educational psychologist. And around, I don't know the year, I forgot, I think it was 1950, he came out with, this is called Bloom's taxonomy. And Bloom's taxonomy is it's the hierarchical level of cognition. And so with Bloom's taxonomy, it says, you know, there's 6 levels: knowledge, comprehension, application, analysis, synthesis, and evaluation. So, for example, we could say, how can I do this? This is, I have a spoon. Okay, you need your child to say, this is a spoon. You go to your 3-year-old, say, this is a spoon, right? And you go, and the child goes, yeah, it's a spoon. Then you put it in your pocket, and you come by, you know, 10 minutes later, and you go to the child, what is this? And the child will say, this is a spoon. Okay, and that's good because they have that knowledge. Okay, and that's in robotics. That was a big thing, being able to identify things. You know, 1 equals 1. You know, that's a big math concept, right? And then what you do in comprehension, you have an understanding. So you go to the child and you say, okay, and you go to sitting at dinner and you hold up the spoon and you hold up the fork and you say, which one's the spoon? And a child that has an understanding of a spoon will say, this is the spoon. And if they can't, you know, you got a problem. And then you have application of what can you do with a spoon. Okay, and you eat soup with it. It's not really good for cutting meat, but you can eat spoon or chicken or cheese, or if you're vegetarian. And then you can do analysis. You say, okay, so here's my spoonness and here's my forkness. How can I make? What is there about this? These are eating utensils. They move things. And then you can look at it and you can say, okay, gee, I have a spoon and I have a fork and I have a problem. I have a problem in that if I run a prison and I have to do what's called a utensil count. I don't know. Anybody ever been to prison here? I did. I worked in a prison, so I've been to prison. And in prison, they have what's called utensil count because the inmates cannot take sharp objects outside of the cafeteria. It's not a good idea. So they want to cut down on what's called prison count. So you, instead of having 2 utensils, a spoon and a fork, you have, guess what? A spoon fork. Okay, and that's synthesis. That's what Bloom calls synthesis. Or you take a ski and a motorcycle and you put them together and you get a snowmobile. Okay, that's what Bloom. And again, the relevance here is this is where robotics and automation is going. We're pushing up through the taxonomy. And we don't have a lot of time here. I can go on for hours about this, but if you start looking at the evolution of robotics, this is what's happening. And the highest one is the evaluation. It's evaluation. So you say, gee, I have this thing called a spoon, and it's good at moving stuff. Maybe I should make a thing called a front loader. And then what's the best front-loading mechanism? So this becomes important. And then we start looking at the aspects of automation. And I'm not going to spend a lot of time on this unless you want me to. Raise your hand if you're saying this is getting to me. And I'm going to go down. So, you know, when we look at automation, you know, we call, you know, I have movement and conditional hardware, software. So for hardware, you know, getting machines to move through spaces, that was a hard one. Okay, yeah, you can say that we can send the rocket moon up to the moon and we have space satellites, but believe me, there's not a lot of negotiation going on in space. You know, if you hit a planet, it's a hard thing to do unless you sort of plan on it. And so movement movement came on pretty easily in robotics. And then in software, I call conditional decision making. Okay, if somebody's wrote a check and there's not enough money in the account, bounce it. Okay, we have software that does that. That's automated intelligence. We move up the next one. Okay, so we have identification. Then for software, I called identification. All right, here's some patterns of pixels. Is that my Bob or is it his dog? Okay, that's a biggie. And machines, and we're doing that. Software does that now. You have fun. You know, I don't know. I didn't know about Google, but if I go to Google search and I put a bitmap in the address bar, it'll go do a search on the bitmap, which I find pretty amazing. And then for dexterity, and this is a big one in robotics, and it's really taking off, is the ability to grasp, okay? And what right now, robotic grasping is such that mostly I can do this, almost like the claw. Claws are very easy to do. And the other one is picking up. You can either do magnetic pickup or you can do suction pickup. Okay, and I saw actually there's a machine out there every year. If you're interested in this stuff, every year in Anaheim is the big manufacturers robotic convention. The whole Anaheim convention center is just filled with robots. And I saw this one robot that was really good, used suction, and what the demonstration is they threw a pile of colored pills on the table. And the robot went through and really bang, 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 took the red ones, put the red one, you know, these are all mixed colors, red, green, blue, took them all, segregated them, and then put them in jars. Okay, and this was just going really fast. I mean, beyond human capability. A human being couldn't do it that fast. So you have dexterity, and we're moving here. Now we have what's called inferential decision-making, what we're calling AI, artificial intelligence, okay? Given what is the best stock to buy, that's inferencing. We're looking at pattern identification. And then we go to, on the hardware side, recognition, okay? Can we identify things and react to them? Now, what becomes interesting is a guy named Jay Tuck, who's out on TED, and this is, for all you out there in TV land, go to Jay Tuck, because I had to contact him because I couldn't get I reference everything I talk about now. But I read his thing, and what I'm about to tell you, I had to go to him and say, can you give me the citation of this? And he said, no, I can't give you the citation of this because it's classified, but you can use me as the citation. So his name is Jay Tuck, and now they are building what's called kill decisions into aircraft. And it's turned off. It's only turned off. Okay, so this notion of recognition, okay, becomes, based with inferential decision making, that becomes very telling. Okay, now networking, and I'm going to take a look, and the implications of networking become dramatic. Okay, we know the canonical example: one fax machine is worthless, right? 2 fax machines have value. 100 fax machines have a lot of value. So the bigger the network grows, the more value gets built into the network. And I'm going to explain these later when we look at the winner-take-all dynamic. And the other one on the hardware side is interaction. Okay, would you really want a robot on the battlefield, on the chaos of a battlefield? Human beings are still very good at chaotic interaction. Okay, that's why the autonomous cars work very well on highways. They work very well in California where there's no snow or ice, but they start getting a little wacky in Chicago or Boston where there's a lot of interaction. But so what? Because I'm going to show you why that doesn't matter. Okay, and then we get to the higher one, and learning. And the ability to learn is the ability, what I call, to create new ideas out of old them. We're going back to Bloom. Remember Bloom? The low part is knowledge, the high one is evaluation. Can I take all the knowledge I have and create new knowledge based on that? And now in software, we're getting there. We're getting there. And then we look at replication. Can we make machines? Like, one of the things human beings can still do, and they do very well, is we replicate. We have the ability to biologically replicate. We can make more of ourselves. Okay, I still have 2, and my 2 made 2, and A, B, C, D, F, G. Once machines get to that point of replication, we have something to contend with. Can machines replicate at a primitive level? Yes, they can now. It's called 3D printing. Okay, so let's do, because I want to talk about this. This is about, now I'm going to come back to this slide again. This is called the rate of innovation, because people are saying, wait a minute, what do you mean? What will we do when everything is automated? It's impossible that everything will be automated. Okay, there will always be people to pick up jobs. And I'm going to say, now I had a thought because I did a presentation 2 weeks ago, and people came afterwards. They were I got a lot of good ideas about this. But let's say that for some reason that we can never go faster than the speed of light. Everything speed, all speed will approach the speed of light, but you can never attain the speed of light because you can't, right? So let's pretend that if it was total automation, there would be no more need for human beings because there would be no more human beings. It's like there's some sort of logical goodness in there, okay? But let's pretend that we can get real close, okay? So let's take a look at history. Something to think about. It took mankind 200,000 years. 200,000 years to get a heavier than air vehicle up in the air. Okay? Wright brothers got it up in 1903. It was worthless because it only stayed up for 60 minutes. A horse could go for 60 seconds, excuse me. A horse was still viable. A horse could the range of a horse was greater than an airplane, okay, at that time. 3 years later, they had it up in the air for an hour. Now its range became viable as a means of transportation. 1906. 63 years later, we put a man on the moon. Think about that. 200,000 years to get the airplane up in the air. 100,003 to get it viable. And 63 years later, a man is on the moon. We call that the hockey stick, right? That's where we all want to get to, right? That's our big mantra, the hockey stick. If we go back, 1840, 200,000 years to get to the steam engine, because before the steam engine, there was only really 3 types of energy: wind, water, and animal. And people forget that for most of human history, slavery was a form of power. You know, the police sat and discussed the big ideas, and the slaves were biogenetic robots. They were the biorobots. They went into the fields and worked. So, and I'm not going to belabor this, but just take from me. So we got this huge acceleration in innovation, okay? Right now, 1940, mainframe, slow as all get out. Now we're all walking around with cell phones. It's a big deal. So keep that in mind as I go on. So I'm saying, look, what's going to happen when everything is automated? I'm saying there's 5 factors to consider, and these are all documented and knowable, and I'm happy to go into as much detail as you want, but I'll do the improvisational one. First one is increase, and I'm going to explain these. I have a lot of numbers coming up at you, so hang tight. And if they're boring, I'll sing, okay? And if I sing and that's boring, well, I'll dance. All right, anyway. Increase per employee productivity. That's the first factor. Faster rates of innovation, which I introduced you to in the slide before. More data, more management. Wage polarization. Okay, and I'm going to actually change. That should be education wage polarization, and the winner-take-all market dynamic. Okay, so let's look at this. I made these in shop. Okay, because I want to play with this. This is I went out, and actually this is interesting. I went out to Yahoo Financial. I did this in 2 hours on Yahoo Financial. I did this chart. Now keep in mind that 30 years ago, this would have taken 3 people a week. 3 people a week, so I'm already eating my dog food. I've become talk about increased employee productivity. Anyway, these are I just went out and picked some companies that were big and people knew about. There was not a lot of rhyme or reason to it. But you see, got Apple has the highest market valuation, and then we have Facebook, and down here we got GM, someplace Walmart. Walmart's a player, right? And then I went and I said, okay, let's look at the number of employees. And you see there's Walmart. Look, almost 2 million people work for Walmart. Okay, 2 million people. And then we got Facebook down here. Like, I think 3 people work there, really. You know, everything else, yeah, Mark and Cheryl and whoever, and, you know, their dog. But anyway, no, it's 17,000. I think it's 17,000 now. But if we look at the net income, look at Facebook. Facebook's off the chart. And look at Walmart. So what we're seeing is a dynamic that it's taking less people to make more wealth.
It would be interesting to see that same chart with median income per employee.
Stand by. Stand by. Okay, now I don't think I hit that one directly, but what it's saying here, now there is a lot of analysis to be done in here because Apple doesn't make sense, but again, and their margins are really good. Facebook's margins are really good. Walmart's margins are terrible, okay, because they're in selling, they have a lot of shipping, they have a a lot of stuff to do. T-Mobile's margins aren't that good either. This stuff, the margin's just not great in here. So what you're going to see is with the increase, and all this is due to automation. When they say increase in productivity, it's automation. You know, 1980, it took, I think it was, I just forget the stat, but IBM, I know, I think it took 60 people to create $1 million in wealth. Now it takes 6.2. Okay, you know, the interesting one for me is that in 1790, 90% of the people in the United States were farmers. Most of the people fed most of the people. By 1970, 2% of the population are farmers.
Interesting also on that last one, which companies are creating something themselves and selling it, and which companies are aggregating somebody else's creation and selling it.
Well, actually, there's a good argument to be made that Facebook does not create anything.
Exactly.
Right, and they're just reselling something they don't even own. But anyway, but we can get into that. But there's a good point. Let's move on. Okay, so again, I did faster rate of innovation. So we got this. We're seeing increased productivity per employee, you know, segmenting up, and then we're seeing the faster rate of innovation. Okay, and I can swear I prove this. And this. Go ahead. No, ask.
On the previous chart, are any of those little red details of historical events significant?
Oh yeah, they all are. Sure. Yeah. Okay. This here, what we hear, I mean, I can go in. Do you mind if I go into these? I'm happy to go into.
Tell us why you've chosen these.
Because okay, that's I had nothing better to do. No, 200 is real. Okay, if we look, let me explain. You asked, you're going to get. All right. So here's the deal. In order to, a friend of mine, Tony, my next door neighbor, who's a historian at Loyola Marymount, is a professor of history. We had lunch one day, and what he told me was that a city can be self-sustaining up to a population point of 70,000 people. If you have no more than 70,000 people, that means that the suburbs are growing enough food to feed those 70,000 people. Okay? After that number, it gets harder. Rome had again, I just don't have this number, so you can call Bob, you're wrong, but Rome had a lot more. I know that, and I think the number was something like 700,000 people lived in Rome at the height of the empire. And this is the decline starts around in here. So what that meant is they had to have military conquest in order to get food imports. So at the height of Rome, the reason Rome had Egypt, it wasn't because they liked the pyramids, it's because they needed the grain and they needed the cotton. Okay, the reason that they invaded the Levant was for really food stuff. Feeding 700,000 people a day takes a lot of food, and it had to happen every day. So we start seeing a decline in here, but this is a big one. Rome declines. Then here we have gunpowder, and 1,000 gunpowder. Remember, I said I sort of lied to you, but I said you had water, wind, and animal. Well, gunpowder is now chemical power, so now we get chemical reactions to produce energy. That's a biggie right in there. Okay, that's why, but that's still a blip in the scheme of things. Okay, then we get the clock. And with the clock, we can start measuring time. And if you can't, you need to measure time in order to be able to travel accurately on the water, the sextant. So then we go into here, again, and I'm doing here, telescope, 1600. That means that now industry is such there's actually that you can actually have a science of glass. So you can do refactoring, and your glass industry picks up. But still, it's really still inconsequential. Okay, then but you needed the glass and you needed the clock to get the sextant, and the sextant is accurate navigation through water. Okay, and then in here, 1840 locomotive. Locomotive transformed the United States. It transformed Europe. It actually was big because before most you either make it or move it in terms of industry, and most movement happened at water. Moving stuff over land was just really inefficient until you get a locomotive. Okay, am I answering your question? Okay, why these are important? 1903, and I'm going to skip here. 1903 is the airplane. 1957 is the computer. 1969 is the first man on the moon. 2000 is the internet. That's really where we have the explosion of TCP and modern networking, what I consider to be modern networking. Did I answer your question, sir?
Yeah. Does that actually say sell something?
Cell phone. Cell phone. Oh. Yeah, cell phone's not possible without modern networking. Okay? Mm-hmm. Good. Okay. Hold your questions or hold your rebuttal. Don't worry. Just don't, whatever you do, don't hit me. That's all I ask. Just don't hit me, all right? Okay, now this is the growth of data, actually. This one here is, this is data, and this, I think I got this from, I wonder if I got it from you all, from Verizon. I'm sorry, but you notice the voice is pretty static, but look at data. Boom. Look at data. Data's just going up there. Data's through the roof. Nobody's talking to one. Actually, there's a good case to be made that we just don't talk that much anymore because we're all texting. A lot of video coming through now. A lot of video.
This presentation.
Yeah, there you go. We're just slamming it through the cell phones. Here's the increase in queries on Google. Right, so there's more data, and because data now more in data, we need more data management. And guess what? You don't. How can I say this? There's no data factory out there. There's no data factory in Detroit making data. People make data, and we apply a service to it, which leads me to this one. Oh, excuse me. Oh, no. This one's mine. I like this one a lot. This is the increase in service labor over manufacturing labor.
What qualifies as service industry?
Blue. Sir, to be honest, I don't have the number in my pocket, but here's what I'm assuming: financial services, food service, anything that a human being is not doing a direct manufacturing, maybe some repackaging, a lot of financial. I can talk about
Technology qualify as a service industry?
tech to software is definitely service because it's not manufacturing. Yeah. But we're seeing the big one is actually the growth, and then this is data scientists here. Growth in data scientists now, big data. And then also what we're seeing here, it's sort of axiomatic. There's, and I wish I did have the numbers and you're giving me something to think about and going back here, but I have a theory that this you have to be a little, I think there's more what I call cognitive ability in here than in here. Okay, because remember the nature of industrial manufacturing is you're taught the job on site. Very few people go to college to learn how to put hubcaps on the wheel or how to do soldering. You're pretty much given a soldering thing to do. So we're seeing here. Then the other thing which is interesting is when we move to services and you see the emergence of financial services, there's a fundamental shift in the work proposition. And in fundamentally a job is you're doing an exchange of labor for money. But in a financial service, you're not. Yeah, people that are making decisions about the money. But when I don't give my labor to my 401k and say, by the way, give me back a return. I give money with the hope of return. So the nature of the transaction and the value proposition is completely different. Okay, and there is some impact there. I don't know if I want to go into it now. All right, this one I found real interesting. So what I did here is I said, okay, so I wanted to show my increase in worker productivity. So I did this one in 20 minutes, where it would have taken 30 years ago, somebody a week and a half. But anyway, and what I did is these are the Bureau of Labor Statistics, and it's the jobs of the future, right? They're doing, here's the present jobs, and they're looking at growth. And if you look at here, what's interesting is that this is the number here of people that these are growth jobs. Now, what is absent here? I don't know. Again, because I've been looking also at BLS for plumbers and electricians. Only 5% of the population is presently plumbers, if that means anything to you. Okay, but electricians are seeing a 14% growth, but I think it's only 5% too. Not a lot of people are electricians. But you can see here, just do the numbers. Most of the growth is in here. So what we're seeing is that what I call the things that require more cognitive ability, there's not a lot of them because their productivity is so high, so you don't need a lot of them, but they are getting compensated more. And the people where the productivity is lower or you don't need to play a lot, there is growth in there. And we're seeing this is actually home health care. There's going to be a great need in this when you're moving people around 70s and 80s. Robots, remember, go back to the analysis I did on robotics. It's still real hard for a robot to take care of an 80-year-old person like me when I'm 80. I mean, there's not that facility yet. You can't move. Moving a human being is hard. The dexterity stuff sort of kicks in. Deciding whether I need to call for the cab, whether I need to call Uber to get the automated car to take me to my client to the hospital, or make him tell the cheeseburger machine to turn on. That's another story. But anyway, we're seeing this wage polarization, and this is significant. This is significant.
Sorry, what does count for that percentage growth?
Go into this chart. Okay, I did this, by the way, on Google Sheets too. This is count ifs on Google Sheets. There you go. Talk about that. Remember, we used to have to pay for Excel. You just have one. I just go to Google Sheets, do it for free. So I'm proving myself. No, this is just in this list. There's one job for 100. There's 3 jobs for 80 to 90, and there's 17 jobs between 29 and 30K. No, these jobs right here. Yeah, the roles. Yeah, different titles. Yeah, or assignations. Yeah, thank you. I hope I answered your question. All right. This one, I did this one last night because it was really bothering me. And I called this a magical graphing. This is like really down and dirty. But what I did is I went out to the Bureau of Labor Statistics and I said, okay, show me the number of people that are college educated. And back here in I think it's 1940, again, I'm not making it, but it's like 3% of the men and 2.7% of the women were college educated. And then if you look here, what becomes interesting here, notice that women are becoming more educated, and actually now more women complete 4-year degrees than men do, which is interesting. And then what I did is I did some cut and paste, and I said, okay, this is 2035, and then I did, this is this is a percentage point here, and we're saying on trajectory, we're looking at 40% of the population will have completed a 4-year degree in 20 years. But if we look at the trends of what it's going to take to play in the economy, that's a scary number because it's not enough. It's not enough. Okay, and I'm expressing an opinion. You look perplexed, sir.
Yeah, I don't understand. Why is it not enough?
Well, I'm going to get to that. Thank you. Yeah, you're good. You can come to my talks all the time. All right. Okay. Here's why it's not enough. This is called, and this is not a nefarious issue. For me, this is a dynamic of networking, of the physical, of just how networks work, okay? And networks, I go back to the fax machine. 1 fax machine is worthless. 2 fax machines are now worth. 100 fax machines are exponentially worth more, make each fax machine worth more, okay? So what this says here, there's 3 graphs here. This is what it's saying, winner take all. Back in 1970, because back in 1970, keep in mind, nobody here, I'm probably the only person that remembers baseball in 1970, but if you notice, in 1970, there were no Japanese players in the league, okay? There were very few, there were no Cuban players, there were some Hispanic players, but since 1940, actually, after World War II, baseball became endemic in Japan, but there was a growth in international interest in baseball. So there became a lot of very good baseball players, eventually. But if we look back here in 1970, this was the league minimum, $12,000, and this was the average salary for the player, and you can see it was 3 times as much. Okay, when we get up into here, we see the league minimum is $400,000, and that's Marvin Miller and free agency. But if we look, the average of the highest paid players are almost 9 times as much. So what and keep that in mind, put that aside for a second here. And then if we look at CEO pay, we're seeing the CEO made 20 times as much, and then we're seeing up here he's making 10 times as much, maybe almost 12 times as much, and then there's a drop because of the recession. That's the second one. This one is really interesting to me. This is if you're a musician, anybody here a musician, ever wanted to make money being a rocker or anything? I did. Anyway, so if I wanted to be a rocker, right, what I could do, if I wanted to make minimum wage, a month's worth of minimum wage, back when CDs were the major medium of delivery, all I had to do was sell 143 CDs. Okay, 143 CDs to make minimum wage per month, which if you're a musician, that's pretty good. Okay, most musicians do not make that. If we look over here, now what I'm going to assert, no, I can't, is that the delivery mechanism is a networked delivery mechanism called Spotify, okay? And that in order to make minimum wage, you have to have 4 million spins. Okay? So Beyonce does not have that problem because her network is very big, right? Mark Christian from Merle Jagger, he's starving. Okay? And it's not an affair. Again, there's nobody up in a tower saying, I'm going to start screwing mankind. I think it's just the nature of networks. The nature of networks, okay, that has to do. And what we're seeing now is with the networks is that you have to, going back to this one, in order to be good in baseball now, because it's a global, the network is very big, you've got to be really good, but you're rewarded, you're compensated accordingly. The more you know, the better you know, the higher you make more money. Okay, and read Martin Ford's The Rise of the Robots. He goes into this exhaustively. You might, if you're interested. And so, well, what does that mean? Okay, so wait, I'm sorry, I don't have my forward slide here. Okay, so what does this dynamic mean? What we're seeing now is we're seeing, some stuff. We're seeing that you got to be really good to play, that education, or no, we'll say cognitive ability starts to count a lot more. Go back. It takes data science. Data scientists, look, there's a lot of data scientists out there, and I'm starting to play around with that stuff. Okay, and I do spend my afternoons now watching YouTube for free. Think about that. Because actually GDP doesn't measure that, which is interesting. But you have to do a lot more. So what does this all, so the question we all came here to answer is, what are we going to do when everything is automated, right? And what I'm going to say is it depends. It depends. And the thing I say, okay, we're either going to, here's the spectrum. Suffer or prosper for the average person. Okay, suffer or prosper. Okay, and what does it mean when this all comes out? Okay, and I'm reading an interesting book now called Black Swan by the guy, I forget the author's name, I remember them at the end, but he talks about domains, he talks about domains of reference, and one of the things is he calls it Mediocristan, and he talks Extremistan. In Mediocristan, statistics count, and in Extremistan, they don't. What does that mean? If you take a room full of people and you measure their weight, and you have one person in the room that has 300, weighs 500 pounds, that's not going to really offset the behavior of the entire group or affect the group in its entirety. But if you take another group of people with average income, let's say you have average income, and you put Bill Gates in the room, that's going to affect the behavior of the whole group. And it's a different way of thinking, a different way of measurement. So what does that come out to be? Well, it's, are we going to suffer and prosper? And this is what I call the 3 challenges. So there are 3 challenges that we have to meet. Okay, I got news here. I have no idea how they're going to happen. I have no idea how they're going to happen at all. But I call them the education wage polarization, extended revenue loss, and purpose. Now let me elaborate on those a little. And actually, I'm feeling a little positive now because I learned something last night, which is changing my thinking. If we agree, and I'm going to change it from education. I'm going to call it cognitive ability. If you have a high degree of cognitive ability in a marketable enterprise. Okay, you could be a PhD in philosophy, and I don't know how far that's going to get you, or you could be Wittgenstein, and I don't know how far that's going to get you. But if you're really, really smart, you're probably going to make some money for a while. Some money for a while. So what happens to those other people? Okay, well, they start, either they don't make a lot of money. The middle is being eaten away. The middle is being eaten away. There's not a lot of middle left. And so we have to address that. Now, what's interesting, I heard last night, I hadn't considered this. My chart about college education, about how we have to, goes now, I'm getting, what's your name, sir? Stan. Okay, Stan. Now, why is that 40% not enough? Okay, because even if you only go to 40% of the educated people, that's the average education. I'm not even going into higher secondary at the doctoral and postdoctoral level. Given the work that's going to be available to be economically viable within that upper range, that upper 5%, that means that there's still going to be, that even those 40% are not going to be able to play, okay? And that they're not going to be able to play, so they're going to go down. If it's up to 80% is at least getting a 4-year degree, that means that maybe 20 to 30% of them are going to play. So that's why I mean that number's just too low. However, what's interesting I thought about is what's happening now is because college is becoming exorbitantly expensive, and because of the debt ratio, that eventually you're going to see a lot of bankruptcies, and that unless something happens. But the burdens are going to become unbearable. But it's like anything else. When it became when driving a car, when gasoline became too expensive, people stopped driving or they bought a bicycle. Okay, let's use that example. It's a little fantastic. Well, when college starts becoming too expensive, what industries will start looking more for certifications. And so it'll become irrelevant that you have a BA in computer science. What they're really going to want to know is, can you do low-level memory management under Malloc? And are you certified in Malloc? And we're seeing that emerging. Yeah. Yeah, it's right. I'm telling you that all of you for 20 bucks a head. Yeah, there you go. Yeah. So that's encouraged. So we're going to see, and we're seeing a lot more of that actually business associations are starting to issue more certifications. Java's had Java certification for a while. I don't AA+. We're going to start seeing more of that. So, but that has to be addressed. because those people aren't going to go away. Okay. The other one is what we call extended revenue loss. It used to be in the old days when the factory closed or your means of work closed that there would be, you'd go and just get another job, right? Well, those no, because go back to that acceleration, that hockey stick, those other jobs of that nature at that skill level, at that cognitive ability level might or might not exist. Here's where, now, and here's, and I have another parable, but I won't share it here. But what happens if you take somebody, something to think about, and you say, okay, you're out of work, and now we're going to put you into a 6-month training program. You don't mind if I use you, because I loved your talk. I loved your talk. Yeah. Do you think I should get the amber incense, or should I get the rosewood? Anyway, so here's the say, okay, we have a huge demand for people that can do low-level memory allocation, okay? Okay, we're going to send you to low-level memory allocation school. Okay, how long will it take you to do it? Let's say I don't know anything about I can type email, and we're going to take you from type email, and somehow magically the curriculum is going to be spot on, everything is going to be rocking, it's just going to be point on, and we send you to this 6-month memory allocation school, right? And eventually you get out in 6 months, and you're just doing this low-level stuff and all that good stuff. Meanwhile, 4 months earlier, somebody automated it. Now what? And this is what we're seeing. We're seeing the rate of go. It used to be, because when we're at the lower level of the hockey stick, we could tolerate that job substitution. But now, when the rates start outpacing the ability of a human to learn and absorb those skills, what happens? And we see it. We're going to start seeing. We might see extended revenue loss. And what are we going to do around that? The other one is a purpose, and this is really not talked about a lot. Let's say as we approach full automation, let's say we've solved everything. We've solved education, that people that want to be engaged and want to be gainfully employed, we got it down, they're working. People that aren't working, they're getting revenue. They're addressing extended revenue. They're getting revenue. We've addressed extended revenue. What happens when you no longer go to work? Now, this might sound trivial, but it's really important. And this is what I'm going to leave you with. Anybody here have children? Don't mean to ask. Okay, 2-year-olds? Okay, 2-year-old, right? Okay, I have two. As we learned on the terrain, a 2-year-old, when they wake up in the morning, they will go until they drop, right? They have no sense of time segmentation, no sense of purpose. They just go and they drop. And it's up to the adult to come along and say, okay, here's the deal. Get up, okay, get dressed, right? How many kids, if you didn't get your 2-year-old dressed, what would happen? All day, all day in underwear, right? Get dressed. It's breakfast time. Now we're going to go play. We're going to go grocery shopping. Okay, time for nap. Okay, a little more play in the afternoon. Okay, and then, dinner time, time for your bath, time for your story, go to bed. Okay, the adult segments the child's life. They give the child, they start developing within the child an internal sense of structure. Okay, by the time the child goes to elementary school, they've been taught how to accommodate structure. They still can't structure themselves, but they can accommodate. I know I was one of those people that didn't transition well. Okay, but you're given, what that means is the child goes first grade, okay, the days, you have classes, 30-minute classes, math, spelling, A, B, C, D, F, G, recess, lunch, Friday's model day, and you get to bring your stuff in. But the school starts structuring the child so they can start being accountable for themselves. Okay, and before you go through school, you get homework, and then eventually you do your own projects and stuff. You go to high school, and this is interesting. I haven't been in a school, but still in my understanding, in elementary school, the educational experience comes to the child. In high school, the child goes to the educational experience. You move from classroom to classroom. That requires a high degree of ability to transition. You just got to be able to do that. When you get to college, your internal structures are such that you're able to manage your own time. So you don't need to go to class every day. You go to class once a week, twice a week, maybe something that requires daily instruction, calculus or something like that. Most classes once or twice a week, right? And it's up to you to do your homework, to do your research, but you have those structures. They've been developed within you. So then by the time you get to a job, if you don't go to college, you go to a job, at least through high school, you learned how to show up. You learned how to make it to first period, second period, third period, cut fourth period, but make sure you're back for lunch, right? Well, when you get to a job, you get to show up, do your job, And I don't know, I did work in a warehouse. I drove a forklift. I was a quality control inspector in a cheese warehouse. And actually, I have an article coming out next week about that, and it's all about DevOps. But what the point is, 8:30, you showed up, you did your orders. You know, the roach coach shows up at 10:15. You do the roach coach, 10:30, roach coach goes away. You work till lunch, go to the lunch things, you get drunk, you come back, go to work. You know, roach coach comes at 3 o'clock again, you go home, and then you eat. But you have those structures, and a lot of people, they depend on that. I depend on that. We all do. What am I going to do today? What demands are being made on me that I'm going to need, right? We sort of are accustomed to it now because it happens so much, right? Showing up on time and doing your gig. What happens when it goes away? Well, here's what happens, okay? Shell did a study. If you retire at 55, the chances, there's an 89% chance you're going to die within those first 10 years. If you retire at 65, you're going to live longer. Now, I have some questions about what that really means, but still, you got to pay attention to it. Alcoholism among the unemployed is twice the rate of the employed. The employed, 9%, alcoholism is 18%. People that are unemployed, they tend to watch a lot more TV, they tend to put on weight, rates of depression are higher. Now that's just incidental, but what happens when the rate, I don't even know if we can call it unemployment anymore, call it non-employment. What happens when those rates start really going up, right? And we have people sitting home and there's only so much infinite content out there. It's gonna be great for Verizon in a way, I guess, you know. I mean, there is a silver lining to this, right? But there's something to think about, okay? How is that going to be addressed? And I'm not in the prediction business. I used to be, I'm getting out of it, okay? But these are things that we, if indeed, in the future, okay? So the question becomes, what are we gonna do when we automated everything? Because we're getting to total automation.
We're gonna automate the automation.
That's it. But the reality is we're gonna have to do something, okay? And that's really going to be up for you to decide. Okay? Thanks. Any questions?
Yeah, do we have any questions?
Sure.
Here, let's do the questions with this wireless mic so they
For TV
show up on the
land,
live feed.
Yeah, if you want to give me a couple million likes, I'm on my publisher to start noticing my likes are going up, so they'll support me better.
So,
Yeah, really? See, well, afterwards, so now I have to do, now you don't get an altar anymore, you get a temple, right? We'll call it like Rosecranz, gold dome, it'll be very cool. You're gonna have to change your wardrobe. Anyway, okay.
so yeah, first question is, can I get or link a copy of this presentation online? Because I know any number of people that would love to see it that are not here tonight. Yeah,
well, I'll definitely, the video implants are a little weird. What I'm planning to do, and if you want to help me, I was going to do this on YouTube and do a narration to it and put it on YouTube. Mm-hmm. Would that be useful?
Yes.
Okay, I'll definitely do that.
That'd be awesome.
I don't think it'll have the enthusiasm, and I can't, when I start talking about, it's going to be meaningless, but.
I don't know if the live stream is being recorded.
Bob slides from, I think, Scale. I think I linked them to the meetup site.
They might be, yeah.
And the link on the meetup invite is a video on demand. So it's not only a live stream, but it's persistent. So you just have to.
Perfect.
Oh, so this is being recorded?
Scale through my rambling.
Okay,
yeah,
good.
yeah.
Okay, well, can I get it in? Because I can edit it down if I can get it in.
Yes, I'll get you. We'll get you
an
MP4
awesome.
as well.
What's your name, sir?
Scott.
Okay, Scott. Yeah, happy to do it.
Thank you. That would be great.
Sure. Any other question? Sure.
You have this article or you have this topic on opensource.com?
I have many. If you email me, I'll send you the links. I did a series of 4 on DevOps.com. I did one about. I did one. I just did 5. I have a 5th one out there. I have one out on network computing and open source. They got reprint rights for it, but I'm developing a couple others too. What I'm really trying to do is I'm probably being embarrassingly immodest, but I've been requested for a book proposal, so I'm working that. That's why I want the likes. This is sort of sad, but I've written a couple books, and they've done well. But last time I did a book proposal, one publisher turned me away because I didn't have enough Twitter followers. So if I want that bot. I need 30,000. But anyway, so yes, I'll send you the links. I'm happy to send them to you and start. I'm sorry to brag, and I'll send you what I got. Sure, as well as read Martin Ford's book, The Rise of the Robots. I really recommend that.
Go ahead. Take it away, Stan. Let me give you the mic.
I wanted to ask, it seemed to me that your talk is slanted to the perspective of the college-educated, like kind of our segment of society, where really the bigger issue is probably the people down at the bottom, because there's a hell of a lot more of them.
Okay, I'm going to answer directly. And I did this. I mentioned this at scale. First of all, the realization I had is that we live in a bubble. We live in a big bubble. I didn't do the survey here, but I did the survey at scale. And keep in mind, the median income for a family of 4 in the United States is $55,000 a year. I would venture to say, if you're working, very few people in this room are making less than $80,000 a year. Okay, so yeah, it's like, oh yeah, the people down at the bottom, what are they going to do? Say, what possible response can they have? And I've presented this, but actually, you are to be direct. You are seeing the response from the average employee. You are seeing it now. Okay, just think about it.
In the current political situation.
Just think about it.
Yeah, hold up.
Yeah. But the point being, we live in a bubble. So, and I realize that, okay. And there's another good book to read, and I just got turned on to him, and I was afraid to read him because he's so controversial. And that's Charles Murray. Are you familiar with Charles Murray? He wrote The Bell Curve. He also wrote a book called Coming Apart, and I recommend that. And in Coming Apart, he does good statistical analysis. Sadly, he imposes some stuff over it. But one of the things he does a statistical analysis of white America, okay? And what you can see there is the increase in drug addiction, the increase of unwed mothers, the increased poverty, and all this stuff. So it's known, okay? But he had, and the reason I figured now it's coming back to me. So he had this questionnaire answer. How many people in this room here have friends who have limited cognitive ability, have trouble reading? Okay, good for you, right? How many people hang out with people that smoke? Smoke. Yeah, smoke. As a way of life. Hang out. Yeah, that's 4. Okay. How many people here have walked a factory floor, let alone worked in one? 1, 2. When I worked for Gateway, most of the people worked in the factory. Okay, so we've created this. The reason I'm sharing this is we've created these separate worlds, and we are the bubble. We are the bubble. Real simple. Median income, 55,000. Average income, 80,000 per head, if you're working. Go ahead, sorry.
Bob, thank you for your talk. I like your graphs.
Okay, cool. Thank you.
And it gives us another perspective on things. How to phrase this? I'm wondering if it's intentional that you don't seem to be specifically referring. You're not giving us a conclusion or suggesting a course of action. And I don't know if that's intentional or not, if you just want us to think differently, or if you don't want to drive us that way. And to add on to that whole thing about you not giving us conclusions, I wonder, is this intended specifically to refer to systems automation, which a lot of us are involved with, or to talk about automation society in general? Is this a doomsday warning?
No, it's not. It's not. My thinking has changed very recently. Okay, and we'll go. It's called, and again, this book, The Black Swan, which I recommend, talks about it's called the problem of induction. Okay, and the example he uses is called the turkey. Okay, if you were to look at a lifespan of a turkey, let's say you were allergic. The turkey, every day the turkey's getting fed. Every day the turkey's getting fed. The turkey's getting fed every day. So the probability of the turkey getting fed tomorrow is very good, except the Wednesday before Thanksgiving. Right?
Unless he's the one that gets pardoned by
right,
the
unless
president.
he's the one. So the reason, and if you look at the reason I'm not jumping to conclusions, there's 2 reasons. First of all, we have to start considering unpredictable events. Okay, 9/11. 9/11 was a transformational event. Nobody thought just it came out of nowhere. Okay. Another one that was really unpredictable, we'll call it, would be the rise of internet stars. Whoever thought that somebody I don't know about would have 40 million followers? I mean, that's a small country, right? These are unpredictable events. Okay, that's the first thing. So I'm still trying to get my head around that. The other thing is the solutions that are being offered now are a joke. Okay, they're just a fundamental joke. Okay, and I'm sad to say that, because I have grandchildren, I think about this stuff. All right, if we go back, if we look at, one is universal basic income. Okay, universal basic income says what we do, and the American Heritage Institute supports it, as well as Robert Reich. The American Heritage Institute, which is not the most liberal place in the world, they say everybody gets 10 grand a year and all the entitlements go away. Okay? And then you get the other spectrum, everybody gets 10 grand a year and all the entitlements stay. Well, that's a joke, because the median income in this country is $55,000 a year. So great, why not make it 10 cents? Because that's about what you get. Because there's still people going to be running at a deficit. Okay, there's no realistic approach. The other one, which is more immediate, is, and I call that, like why don't we just go to Mars? You know, that could probably solve the problem too. The other one that I was hoping was more immediate was the change in the unemployment laws. I've been on unemployment, okay? I was on unemployment, and it's a joke, because if you're on, anybody here been on unemployment? Yeah, okay, well, rock on. We all know it's a joke, right? What do you get? The average, the median, let's really go for the extreme. In San Francisco, you get $1,200 a month, right, on unemployment. And if you work, you get it taken away. And it's only maybe for a year and a half. So that's a joke too. There's no impetus to allow people to at least have the notion of living. So you put people in a state of living angst, right, living angst. And what we've done is, if we look at the rise of consumer debt, because financial services are very attractive. Financial services are very attractive, is we've risen consumer debt to the point where it's now financing these laws. So, and I'm not answering your question directly, because what I'm hoping for, and this is the research I'm doing now, is how to do it. Might there be a unpredictable event that changes everything? For example, does certification start becoming so prominent that people can really spot jobs, and that we become more, and one of the things I like about open source, I'm not a big fan of open source, because it's in the sense that it's free labor, but one of the things I do like about open source is that the mechanisms for decision making are very well developed. So maybe we can get it together and say, okay, somehow we're going to figure this out, and we will be able to do spot on renewal. Let's call it spot on renewal, so people can actually go in and say, we'll do it. Maybe that'll be the unpredictable event that'll change everything. If not, you know, is anybody French history buffs in here? What happened after the Revolution? Started with an R. Had a weird name, Robespierre. Yeah. Yeah, the terror. Yeah, the terror.
How do we get from where we are to post-scarcity Star Trek utopia?
I don't know.
We go through the terror.
No, I don't. The fast answer is I don't know. But here's what I mean. There's three parts. Okay, there's three parts to this. First part is description. Second part is complaint, and the third part is solution. All right. So here's what I've been doing. I've been doing these. I come now and I'll talk to whoever will listen, and I try to do it in as a least provocative way, and really leave the decision making up to the individual. Okay, but that's one thing. The other thing is I start talking to people about it. Like if indeed the numbers make sense to you, and if they don't, call me, write me and say these are bogus numbers, get them real, and at least what do you think? One of the problems we're running into, and what's his name, Lakoff, the guy that said don't think of elephants. That again, we're living in this bifurcation where logic doesn't count. Logic doesn't count. So there's a problem in there because logic doesn't count. So, but the point is, you know, next to you, start talking. Hey, what do you think? What do you think?
Okay, so to get back to my question.
Oh, I thought I answered it. Sorry.
You did, sort of.
Okay.
Are you warning us in general against automation being a threat to mankind?
No, it's like saying the steam engine's a threat to mankind, or no.
It was a threat. It was a threat to a lot of people's jobs, and some of them adapted and some didn't.
Yeah, so those are the Luddites. No, it's going to happen. It's going to, unless something cataclysmic, or what we call it unpredictable. Unless there's an unpredictable event that stops it. One of the things I think about is, it's real clear. Right now, I've been programming since 1983, actively, professionally. And the other day, my internet went away. And I don't remember anything, and I couldn't program because there's no internet. I couldn't figure out how to do a simple file write under Node. I couldn't copy the code. You know, go figure, right? So what happens if we start seeing major outages? Right? And this is what I'm talking. I don't think it's going to be catastrophic in the sense. Automation has to happen. Okay, it has been happening. The trend is there. Do we run the risk of the induction problem that, you know, it's Wednesday before Thanksgiving? Maybe.
You may want to speak in the mic if you
want. Oh, I'm sorry.
If you want to walk around.
Oh, I want to walk. Yeah, I do want to walk. Is this better?
Yeah.
Yeah, sorry. I didn't even know I had a mic.
Come better on
Yeah. The answer is, do we have the best answer is automation is going to happen no matter what. I would imagine to say everybody here has created a piece of automated or automagical intelligence that didn't exist 3 weeks ago, myself included.
Yes, and at UUASC, our previous talk was on configuration management, which involved a lot of automation of systems, and then Puneet Kandahari's talk coming up will be launching mass automation of server provisioning.
There you go. And then it's going to
hit
right.
hits all areas.
Yeah. Now with serverless computing.
Okay,
Yeah. Anyway, go ahead. Question? Sorry.
Oh, sorry.
Yeah, I'm sorry.
If my voice is shivery, please
No, you're cool.
excuse me. I'm like extremely cold. Am I the only one? I'm like freezing right now. Okay.
Okay, I'm going to stand here now.
Right.
I've been told to stand here.
Yeah. Okay. That was an awesome talk. So my first question is, will you be my dad? That was awesome. That's the first question. And I will follow up on that.
Well, will being your dad involve bail money?
Right. Let's discuss. And I just wanted to basically, it's not really, I don't really have a question. I just wanted just to kind of confirm, you know, a lot of the points that you hit. I've seen these things happen directly. Just, you know, coming from, you know, just my background and just the community that I grew up in and just my demographic. Like I have seen it directly. Even with my friends, it's not even an age thing. Also, like, I don't know if you guys can tell, I'm 23. But, you know, it's not even an age thing. You know, young, old, and it's not even a college thing, whether you have a degree or not. It's just these things are happening. I'm seeing like that middle piece, like you said, being eaten out. And another reference to the college situation about it not being enough. That's correct in so many different ways, definitely more than one way. One being that we're seeing the increase. I guess college is being promoted as the solution, as it's always been. You know, you have to have the 4-year degree. That's why you're not making enough money. You need to go back to school. You need to go back and get your master's. But what are these people, if you're not majoring in or specializing in fields that are directly pertaining to the automation of, you know, the growth of automation, you're still not going to come away with what you need. So like maybe, I don't know, the psychology majors, or like maybe I need to go back to school, psychology and, you know, maybe even finance. You know, if you're not directly hitting on, you know, as far as where the economy is going, which is the growth of, you know, the rise of automation, it's really not adding up. So yeah, and I've seen that firsthand. I mean, I'm a college dropout. You know, I have someone on my team or on the traffic management team that, you know, he dropped out of high school, you know, and so, you know, it really doesn't, the closer you are to touching that rise of automation, the better off you'll be. And all those roles in the middle are just being like, not even counted. So I'm just like, it's just like a testament to say like dead on, which you already know, so yeah.
Right. Well, no. I mean, yeah. There's no. I mean, the trick is for me, is to keep really as much as possible to keep a positive attitude. I mean, you know, in order before you can solve a problem, you got to know you got a problem. right? And this is real. Sadly, you're seeing just there's a lot more advertising about it now, and a lot more discussion, and there's a lot more just going. There's a lot of talk in the talkosphere. Sadly, though, what the missing part is, it's still a description and complaint. There's not a lot of solution out there, and the solution, you know, it can't be, I don't even know if it can be with one person or a group of people. One of the things I have done, and I've been actually, my congressman is Karen Bass, and she, I put myself in front of her, and she heard it, and she, you know, there's discussion at that, you know, at that level. I do recommend that, you know, you do write your representative, or at least get in front of them. There's also, I belong to the Palms Community Council. I belong to Palms Community, I'm not on the council, but the president, you know, Nick Rigg, he understands, he gets it, but we're still at the descriptive stage. But maybe that's where we have to be for a while. But it's real, and it's real.
You know, it strikes me that this is, you know, we're a bubble group. I mean, relatively speaking, at least for the foreseeable future, we don't have really anything to worry about or complain about, honestly. I mean, you know, like you may think we do, but because like this is not a new problem. I mean, problem has been going on since I first got into computing, and it was like in other countries like Great Britain, they were dealing with like, they actually had a bureau to deal with the effects of, you know, automation and technology on the public or on the populace. And the thing is, this is not a new issue, and you know, like this is just a continuation of a trend. But the bigger thing is that like we're a very small privileged part of society, and it's the larger number, the very poor and the people who are essentially now almost disenfranchised from society, where, you know, that's the issue that has to be addressed. Because, or that's my feeling, because there's more of them. And I'm telling you, you know, like, if you're thinking, you're just worrying about our little small segment of society, you're missing the boat, because the change is going to come. You can't stop it. And like, people like have been talking about this, like, for years, like, you know, you go to the Hammer and like they'll have presentations on the gap and like the growing gap, and like people are plain worried about it because like something's going to happen. It has in the past in this country, and it's going to happen again. If we don't, you know, if we don't like say, you know what, this is not acceptable, or we have to kind of at least, you know, like we have to address what's going on, because if we don't, you know, like, when you can't make a living, and you know you're told that you don't do anything worthwhile in society, and like, and you know like, but you've got to like go along with what's going on right now, you know, and they're taking away your health care, and they don't want to like give a living wage or anything. It's like, well, how are all the people going to react?
Well, something to think about is I don't think that we're exempt. I don't think we're exempt. I think if we start looking at, I'll just look at release management, and I'd have to have the numbers. The good news that we're saying, oh, the volume is greater now. There's more need for release, but that's all automated. I mean, how many people here used to load servers on zip files? You know, it's not done.
Think about the stuff that you do now if you're in operations and the stuff that you did 20 years ago. I mean, like 5% of what I did 20 years ago, I'm still doing today, and the rest of it is all software's doing it for me.
Right, and what's going to happen? Go back to the curve. Remember, the per employee productivity is going up, so that doesn't mean that I have to hire another person to increase my productivity. What I might have to do is fire an engineer and get a more talented one. Right, but again, follow the logic though. Okay, let's say Stan. Okay, you know how to do A, B, C, D, F, G, and you're producing. Let's say your per employee is $1 million. Okay, you can produce $1 million in wallet, and your automation levels are such, right? But you've been doing your A, B, C, D, F, G, right? You haven't been. Let's say, and I'm not saying you. I'm just saying a person. And then somebody comes along, and then there's been a new technology released that if you learn and master it, and let's say it's really hard, okay, and most of the stuff really hard is, but I can bring in a person now that's going to do it, and that's going to be have 1 week of simulation time, and then I can get them to be productive in the next week, and they're going to make me 1.5. Who am I going to hire? Now you say, okay, that's great, and now person A goes into the training farm, right? But I mean, we don't know. I mean, that's just the point is we don't know. But I don't really think that we're that exempt. I really don't think so. I just don't think so.
You know, you're probably, in the long run, you're right, absolutely. But, you know, like, I think we really are the elite in this society.
Oh yeah, and so is Robespierre.
Yeah, one other, I
It's a
don't know,
joke. He was killed.
one other cool sci-fi book on the topic is Kurt Vonnegut Jr.'s Player Piano.
Player Piano.
Oh yeah, that's some fun reading too.
Yeah. Your point. Any other questions before? So we've been here late. What?
Hold on. What?
Quite a number of questions seems to be
No,
a
good.
really
That's
good
why we're
topic,
here.
Right. Just wanted to say thank you, and it's a very interesting topic towards, I think it's not necessarily on the technical side, but on the philosophical, and make us think. I just want to point out that in a couple of slices you had purpose, and how does it play that, you know, our purpose within all these changes. What does that mean? We're living in a society that is very materialistic, and how do we deal with these changes? Obviously, it's not necessarily the most educated or the one with the most titles that will survive. It's the most adaptable. These changes are coming regardless. Some people would not make it to be able to adapt. But then, what does it mean if they have a purpose that it has nothing to do with material wealth, with money, but with what life is all about? Does that make that person less than the one that was able to adapt to all these changes that are coming?
Yeah, I can respond to that. Yeah, let's talk about what happened in Baltimore, which is an interesting use case because we're dealing with statistics. We're dealing with statistics, okay? And just to put things in perspective. Right now, there are 100 million people working during the workforce, okay? Of which 32% are college educated. That means that 70%, 70 million people are running around with jobs that sort of either require training or a trade skill. I'll give you a trade skill, but if we look 5% of that. So the number, we're dealing with a lot of numbers. So this notion of philosophical imperative, or, you know, yeah, I call it the Picasso problem. Picasso never had a problem what he was going to do in the morning, but there are not a lot of Picassos around. So in Baltimore, what was interesting, Baltimore used to be an industrial city, and the industry left. Okay, the industry left. And what we saw is that, remember, it's not what is the purpose? And one of the fundamental needs a human being has is the ability to structure their daily life, not in some, let's keep it real simple. What is my sense of ego about? How do I structure my personality? All that good stuff. So what was interesting is as the factories left, the gangs increased. And one of the things that gangs provide is structure. They provide hierarchy, they provide structure, they provide imperative to do something. And there was a great, everybody read Freakonomics. I mean, a crack dealer only makes minimum wage. I mean, that's the reality, you know. So, but when you do it, but that's what you get. And because that structural organization has gone away. Now, there's a good case to be made. Well, okay, what other structural organizations are there? Well, there are religious ones. Okay, you know, the church, you know, mosque. Okay, you got that, and there's a lot of that. It's interesting. We're seeing the rise of evangelicalism. Not so much. I don't know if it's so much belief-based, but is it providing the psychological structures one needs to get through daily life? All right. So the question becomes, and then what will we see? Are we going to see just rampant people sitting around watching Netflix all the time? Okay, I have two parables, and then I'm going to, unless there's questions, I'll change it. First one's about, I'm going to share intimacies. They're about me. Okay, my mother was a nurse. Okay, she was a nurse for 25 years, and her job was she worked in an operating room assisting doctors. My sister is a nurse. She's in her 30th year, professional 30th year. Her first 25 years, she worked in an emergency room, okay? The last 5 years, she's worked in what's called a online triage. She answers the phone and makes sure that the helicopters show up and the right doctors show up. She coordinates medical delivery. My daughter's a nurse, 2 years out of nursing school. Her first year, she did direct service. Her second year, she's on the phone. Okay, so, and what she does is she does pharmaceutical administration, telling people what drugs to get, taking care of their drug needs. Think about that. A full lifetime of direct human-centered service. My sister, right, what's the math? 18%? 18% of her life, 72% direct human, 18% on the phone. My daughter, half. Now, most of her life is going to be, if she continues nursing, she'll probably be on the phone. What that means is the minute you put human interaction into the phone system, it's subject to automated intelligence. It's the easiest path to AI. Answer the phone. Anybody ever got on the cell phone and said, are you human? Right? Right? So, that's the first thing, just, to go back to the, and I'm going to be absolutely honest with you. I forgot what the second thing was. Yeah. Yeah, I can see how you could think that way. I get it, but it doesn't work that way when the refrigerator's not full.
Interesting also to consider how we've been talking in the context of society in the first world, the United States.
Mm-hmm.
Most of the people in the world aren't in that society, and the things that we've been seeing around automation, unless they involve automating the food supply, it's something that's going to hit much later, if at all, for people in the pre-industrial world, in sub-Saharan Africa, Southeast Asia, places like that where people aren't yet, where their society structure is not information-based or service-based like ours, where it's still a lot of subsistence.
Yeah.
It's going to be interesting to see how automation in the developed world affects the world that's less developed.
Well, let me address that directly. There are 1.1 billion people in China. Okay, there are 800 million going to 1 billion people in India. Okay, Nigeria is down there, just because I have a study with that. Nigeria is at 100 million. Okay, that's less. The United States is 300 million. So all those other they're not a blip. They're not a statistical blip. The ones that really are is India and China. Okay, and now what's interesting, if you start looking at the rate of capital investment in robotics in China, it's really very big. So all those people that came in out of the countryside are going to be replaced. Okay, and so now China really has a big problem on their hands. Okay, and also China is going to start moving after manufacturing. They're ahead on financial services, and as we look, financial services is just a whole other critter completely.
Nobody ever starts out as an industrial engineer. When did your interests diverge into it?
Into what?
Industrial engineering.
Oh, when I worked at Gateway. Gateway was the big one for me because at Gateway, I went to Gateway. I was a software engineer for Gateway. They didn't have a big software presence, but I was there. But I really, I've always worked in warehouse. My father's a cab driver. My father was a cab driver. I don't come from a very wealthy family at all. And I've worked in I've worked in warehouses, I've worked in factories through school. I drove a forklift. I knew how to do all that stuff, right? But when I got to Gateway and I started seeing what and Gateway had it down. They could put up a new factory in 18 months. They really knew how to do that. They understood that quite clearly, particularly during the expansions. But because of that experience, also remember the way Gateway was very smart is they understood the need for a labor force. And what they were very good at doing were taking people that were meat cutters and turning them into assemblers, computer assemblers. That was their labor force. And because the meat cutting, it's also interesting. When we look at automation, people don't spend a lot of time on agriculture, but the big automation guys are agriculture and mining. And if you look at agriculture, it's like, I mean, one person can farm 1,000 acres, can plant 1,000 acres in an afternoon. Those are called part-time farmers. Most business now is agribusiness. But also when you start looking at what happened, I learned a lot about beef cutting, the science of beef. And it really is like automating the slaughtering process, what that did. At one time, every supermarket would have a butcher that could take apart a cow. They're not there anymore. It all comes in boxed beef. So the only skill you have to know, it used to be being a butcher is a skill. It really is. Taking a cow apart or a pig apart, that's a up there skill. But cutting down boxed beef or boxed pork is nothing. You can teach a kid to do that in an afternoon. You can teach a robot to do that now. Okay, and if you look at I suggest you look at Rethink Machines. If you look at how the way they teach robots, there's not a lot of most programming for robotry is done what's called PCL process control, PCP process control language process control library, which is graphical programming. They just move the pictures around. But mostly what Rethink Machines is they have a technician sit and teach the machine how to do the movement. So just, going in and slicing down the cow, that's going to be nothing. Getting the box beef in, quartering it down, getting the rib, that's going to be nothing. So the way I got it was a Gateway because I just saw it on a massive scale. And actually there's the National Association of Product Manufacturers and the National Association of Inventory Controllers. They're huge associations. We've been making stuff for a long time. Okay, Smith & Wesson's been in business for a long time, even before GM. Okay, Singer Sewing Machine has been in business for a long time. And so the science of industrial manufacturing is well known, but we live in the bubble. We don't see it. Any other question? I think I'm keeping you after school here or something. What?
No, I just wanted to, it's my impression that China has the advantage that they do have a purpose. They have a national purpose. And they stated we're going to convert from an agricultural economy into, industrial, more, contemporary economy. And they have a national imperative to we got to deal with all those people. They have programs when you're a senior, they have a damn college there you can go to so you have something to do. I mean, and they have purpose and they have belief, which in this country.
Yeah, speaks well of democracy, doesn't it? You've been more than generous. We got to go.
Yeah, we should probably. Okay, yeah.
Thank you
so
for your
hey,
time.
Thanks everybody. Yeah, thank you, Bob. Yeah. I'm glad we broke this talk from the Scale DevOps Day because we had time to do the Q&A stuff. This is probably UUASC meetup. This is probably the longest Q&A that we've done, and it's definitely the latest running.
Oh, yeah.
So thanks for sticking around.